Okay, this tutorial is looking at the difference of two squares. So the difference of two squares has a rule that if we expand something like a plus b times a minus b, we get a squared minus b squared. You can do this expansion using the distributive property, and you will get this. Now, in reverse, because we know that when you expand this, you get this, we can actually say that when you factorize this, you will get a plus b, a minus b. So we're saying that to factorize difference of two squares, a squared minus b squared is equal to a plus b times a minus b. So this property is how we factorize using the difference of two squares. Some examples of this. So we are asked to factorize the following, and the first one is c squared minus 81. We can rewrite 81 as 9 squared, so c squared minus 9 squared. Now in this particular case, the c is represented by a and the 9 is represented by b. So using a straight substitution, we can factorize this to get c plus 9, c minus 9, and that is fully factorized. In the second one, a squared minus 5. 5 is not a square number, so what we can actually do is take the square root of it and then square it. So this is a third property that we've looked at previously, because we know that that square root and that square will cancel and leave us with 5, so this is accurate. What this means is our b value will be root 5 and our a value is a. So we can factorize this to get a plus root 5 and a minus root 5. Example C. 8 and 2 cannot be changed into a square number, but 2 does go into 8 and 2. So we're going to pull 2 out as the highest common factor, leaving us with 4d squared minus m squared. At this point in time, the 4 value is not being squared, so we have to actually still change this. So we're going to change this so that we can get 2 squared, or 2d squared, minus m squared. This conversion here is a property of our indices laws, which means that I've got something squared minus something squared, so I can use the difference of two squares and factorize this, giving us 2d plus m, 2d minus m, and that's all multiplied by 2, that highest common factor that we pulled out at the start. Example D has the expression z minus 2 all squared minus 1. First thing to note is that that 1 can be written as 1 squared. What this means is that when we do a is actually the z minus 2. So this a portion is z minus 2 minus the b, which is 1. So z minus 2 plus 1, and then also z minus 2 minus 1. Simplifying those brackets, we'll get z minus 1 and z minus 3. So that's now fully factorized. Now the next example requires us to factorize this in parts. So we're actually going to look at the very first section and then the second section as separate things. So we've got x squared minus 6 squared. That makes sense. We've got x squared there. 36 can be written as 6 squared. And I'm not going to change the second portion, so 2x minus 12. The x squared minus 6 can be factorized using difference of two squares, so x plus 6, x minus 6. And the 2x minus 12, 2 is a highest common factor and can be removed, so 2 bracket x minus 6. Note that we have an x minus 6 in the first part and an x minus 6 in the second. In fact, that's a highest common factor and can be pulled out the front. This will leave me with, x minus 6 out the front, and leaves me with x plus 6 plus 2. 6 plus 2 is 8, so my end answer is x minus 6, x plus 8, and that is fully factorized. So each of these has been done using the difference of two squares rule in order to factorize.